Part of this chapter is the intersection of graphs. So let's look at example 39. 39a is asking us to sketch x squared, y equals x squared and y equals 1 on the same set of axes and hence solve x squared equals 1 graphically. Okay, so we're not really going to go into sketching of graphs here, sketching of parabolas and so on. And how to sketch a parabola, that's in 308. So if you've been unsure about that, go back and have a look at 308. So we're just going to focus on points of intersection and how we can link that to simultaneous equations. So look at the graph here. You've got 2 points of intersection. The first point of intersection is at x equal to 1. The second, so at negative 1. And the second point of intersection is x equal to positive 1. Now when you look at these two equations here, y equals x squared and y equals 1, if you solve these equations simultaneously, you would then end up putting x squared equal to 1. Now solving these equations simultaneously, doing it algebraically, and looking for the point of intersection of the two graphs, gives you the same results. So when you take the two graphs, you sketch them, and you look at their points of intersection, and the solutions to these simultaneous equations here are the same thing. So x equal to 1 and x equal to minus 1 are the points of intersection, the x values, and it's also the solution to this equation, which results from the simultaneous equations. Now for part B, we're looking at a similar technique. Graph the parabola and graph the horizontal line y equals 2. Here are your points of intersection. So you've got x values, x equal to negative 1 and x equal to positive 2. Now similar to part A, when you look at this example, let's say you look at the equations y equals x squared minus x and the equations y equals to 2. If you solve them simultaneously, you're going to end up with x squared minus x equal to 2 using substitution for solving simultaneous equations. So algebraically, you'd go about solving the quadratic equation, bring 2 over the other side, get the solutions. Now, if you did it graphically, you're just going to graph y equals x squared minus x and y equals to 2, and their points of intersection will give you the solutions to the simultaneous equation. So x equal to negative 1 and x equal to 2 are the solutions to the simultaneous equation. And if you solve this equation algebraically, you'd also get x equal to negative 1 and x equal to 2. So you can confirm that if you like. Okay, for example 40, you're finding the point of intersection between the two lines. Now, here we're going to go the other way. We're finding the point of intersection between the two lines, but instead of actually graphing the lines here, we can solve the equations simultaneously, and the solution to the simultaneous equations will give you the points of intersection of the two lines. So it's the opposite of the previous example where we did it graphically, and the point of intersection gave you the solutions. Here the solutions are going to give you the point of intersection. So solving them simultaneously, let's do this through elimination. So let's look at the two equations here. 2x minus 3y minus 3 equals 0. And 5x minus 2y minus 13 equals 0. Now to solve them using elimination, we need to be able to match up a couple of terms so that if we add the equations or subtract one from the other, they're going to cancel out. So let's look at the x terms, 2x and 5x. Let's try and get these terms both to 10x. So if I multiply the first equation, so let's call this equation 1, call this other one equation 2. So let's take equation 1 and multiply that by 5, and equation 2 can be multiplied by 2. So multiplying equation 1 by 5, you end up with 10x minus 15y minus 15 equals 0. Looking at equation number 2, here we're just multiplying it by 2, so you're going to get 10x minus 4y minus 26 equals to 0. What I'm going to do is I'm going to take the top, take the top equation and subtract the bottom equation from it. So 10x minus 10x is going to be 0, they're going to cancel each other out. Minus 15y minus 4y, it's like minus 50, so it's minus 15y plus 4y. So minus 11y minus 15 minus 26, so minus 15 plus 26. So plus 11 equals 0. So I end up with negative 11y plus 11 equals 0. And then I can solve this by going minus 11 on both sides. Minus 11y equal to negative 11. Dividing both sides by negative 11, I end up with y equal to 1. So that's our y term, and then we can use that. So now we can substitute y equal to 1 into equation 1. So doing that gives you 2x minus 3, so instead of 3y, 3 times 1, minus 3 equals 0. So 2x minus 3, so 2x minus 6 equals 0. 2x equal to 6, and x equal to 3. So those are your solutions, y equal to 1 and x equal to 3. So your point of intersection is going to be 3, 1.